Okay, so following on from our CentOS minimal install, we're going to now set up our LAPP stack, which is Linux, Apache, PHP, and Postgres. And this is the staging server that we're going to use as part of the development for the project over this semester. Right, okay, so let's just quickly make sure that we have the latest packages of everything in. So into the operating system. Yum upgrade. Yum is the package installer which we use inside CentOS, and it basically looks at a lot of application repositories which are provided by the Red Hat guys, and then it just pulls in the various different bits of software that it needs. Obviously this is the first time this has been run from the installation media, so there'll probably be some updates to pull down. And there are quite a few. So just hit yes on that and let those install. If you come across this, these are the GPG keys which are signing the certificates from the repositories. So just accept these. Okay, so that's done now. It brought in a new kernel as the updates have occurred. So let's just reboot the machine using the reboot command. And then we can select the latest kernel as we move back in. Okay, and we can see that there at the top there are now 2 kernels installed in the system, and this is the latest one from Red Hat. Okay, and then let's log back in as root. Okay, so we've now got some bits and bobs that we need to install, which will underpin our development and help us out as we move through this. So let's use the yum command again, install, and then let's add a list of tools and utilities that we'll need. So we'll start with yum utils, which bring us some utilities to help us with our yum installations. Nano, which is a very lightweight text editor, which is very easy to use. SE troubleshooting server, which will help us with the underlying SE Linux security system. We may need to alter bits of that. elinks, which is a command line browser. EPEL release, which is the Enterprise Linux Extended Packages repository data for some additional software. And DKMS, which is part of the kernel compilation tools which we'll need. Delta RPMs for managing our RPM database. And that'll do us for now, because we've got some more to put in afterwards. So let's just bring this lot in, which will help us with the installation of the next set. So that's brought in our software and our dependencies. So let's bring those in. Now let's use yum again. You've got the opportunity in yum to use the group install, which allows us to install a bunch of packages in one go. And this time we're going to bring in the development tools. The uppercase letters are important in this. This is a bunch of stuff that you use to develop software in. Various different aspects for compiling kernel headers and various other things that we need. Okay, so that's brought us in quite a chunk of software. Let's just go ahead and install those. Okay, one more package now. Yum install kernel development tools, which will need to compile drivers for VirtualBox and make sure that they're inserted into the kernel. So let's just install those. Not a massive package. Okay, now we can go ahead and install the VirtualBox drivers that we need for the OS. So up onto devices and then insert the guest edition CD image. Okay, and then we'll need to mount that onto the file system. So use the mount command, -R, and it'll have inserted it into dev CD-ROM, and then we'll mount it onto media, which is an empty file on the file system. Okay, that's mounted, and if we CD into media and look at the contents of the directory, we'll see that that's the contents of the mounted CD-ROM. And we want to install the VBox Linux editions, so we'll go ahead and do that. Okay, so that's the VirtualBox drivers installed into the kernel and running. As you notice, the screen size changed, so that's because the resolutions are different now. So make sure that we've got all of those running inside the kernel. We'll just do a quick reboot. Select the top kernel again. And then we'll log back in as root. Oops, typo. Right, okay. Clear the screen down. Right, so now we're going to go ahead and install PHP. CentOS provides a base version of PHP 5, but we want to use PHP 7.2, which is one of the latest ones that have been released. In order to do that, we have to import a different repository of software, and we're going to use the REMI software collection repository. It's a quasi-official repo which pretty much focuses just on PHP and the PHP development environments and different frameworks. So we'll bring in the repository for that, which is on the web. So yum install http://pms.net. Okay, and that should bring it down. Maybe not. There's the typo. There we go. Okay, I'll just install that in. Okay, so now we can go ahead and look at installing our PHP versions. We can use yum to find out some information on a package. So let's just see what information it's got on PHP. Okay, now that's using the standard 5.16 one. So after we've installed the REMI repo, we need to enable it using the yum config tool. So yum config manager, and then we want to enable REMI PHP 7.2 repo. Okay, that's that done. Clear that down again. Okay, so we can use yum info again and see which version of PHP we've got access to now we've enabled the repository from Remy. Okay, and now we can see that it's bringing in version 7.2.1. So as I said, with the Remy repository being kind of quasi-approved, it overwrites the versioning for the base packages without actually altering any of the other base packages within CentOS. So this enables us to create an environment where we can develop with the latest versions of PHP without having to adjust any scripts or anything like that to point to a different version. Okay, so let's bring and install the PHP package. Yum install PHP, and then the command line PHP CLI, which for the command line interface, and then we want PHP pair, which is a repository of different pre-built elements such as database access layers and various other things which you might find useful, especially if you want to produce PDF forms and things. There's packages in there for that. And then HTTPD is the web server, then HTTPD tools to bring us in some tools to support the web server. Okay, so let's just hit that and just check we're getting it from the version. Yeah, so that's coming from the updates repository from Red Hat, and these are coming from the Remy repository. Depending on the state of your operating system, you might end up with some additional dependencies. So don't worry if you see extra packages in there. So is that okay? Yeah, let's install those. Right, great. Okay, so that's that installed. Right, so now let's just check some permissions on the directories before we start going ahead and tweaking our web server. So the web server itself serves the files from var www html. Okay, and we can list the contents of that directory, and there's nothing in it. If we also look at the permissions of the HTML folder itself, right, we can see that they're owned by root. Okay, and that's the owner list, and we can say that also the group belongs to root. Because the Apache web server runs under its own user called Apache and belongs to its own group called Apache, then in order to enable Apache to read into this directory, we're going to change some permissions. So group, to change the group, Apache, so that becomes owner and group of the file. www. Okay, and we want to make sure that we recurse down into the subdirectories as well. What about that? Oh, my mistake. Should be change own. There we go. If I just wanted to change the group without the owner as well, I'd use group. Just let's see that's happened. Right, okay, and there we go. We can see that that's changed now to Apache. So everything's good in terms of that. Let's just change the permissions on the directory using the chmod command. And we'll change the permissions to 755. If you don't know how the Linux permissions work, we've got these bits here, RWX, R-X, etc. Well, the 755 represents the binary values. So read, write, execute would add up to 7 because the X is worth 1, the W is worth 2, and the R is worth 4. So that would be 7. Read and execute is 5. Read and execute is 5. So chmod 755 minus R to recurse into the directory var www. Okay, now that's done. So let's clear that screen a little, give us some more room. Now inside the var www.html directory, we're going to create an index.php file. So we'll use nano, which is our text editor, var www.html index.php. Okay, and we want to enter in the PHP info, semicolon, and then close the PHP tags. Okay, and we'll save that using Control X, as you can see down there, to exit. And then it's asking if we want to save modified buffer. We'll go yes. File to write to, just hit enter. And then if we look in the list of contents, HTML, right, we can see that we've got the file there. Because we've got the flag set here, it's because we created it as root. We've got read and read set. So even though root is the owner, the group Apache should be able to read it, and any others should be able to read it. So that should be fine. If not, we'll come back and change them in a little bit. Right, now let's go on and tweak our Apache configuration file a little. Apache's configuration file is stored in the etc directory, so we'll have to just navigate to that one. So using nano again, go to etc, can't type, and then it's httpd for the web server, then it's in the conf directory httpd.conf. Most configuration files in Linux end with a .conf suffix, so it should be fairly easy to recognize, and most of them are just text files as well. So here we are. Might seem a little scary at first when you're looking through this, but a lot of it's comments. It is worthwhile spending a few minutes reading around them, so at least you get a vague understanding of what's going on. As I said, the server root is in etc httpd, which is where we are now. Apache is listening on the standard HTTP port, so port 80. These are looking at various dynamically loadable modules that we can have in there. As I said, Apache runs under a user Apache and the group Apache. And then these are the main server configuration files, which tell us various different permissions in terms of serving from our document root, which is var www.html. And the permissions to access to read in those. Okay, but what we're looking for is something that relates to directory index, and here it is. Okay, this, if we request just a directory, so like the root of our web server, then Apache at the moment will only serve out index.html files. We want it to serve out index.php files as well. Okay, so that will allow us to serve both of those out. You can, if you want, be explicit and add it onto a separate line. It doesn't matter, whichever's clearest for you. Okay, so save that, Control X, save the modified buffer, yes, and then write it to the configuration file. Okay, so now we've done that, we need to add Apache to our firewall. So firewall command, add it to our permanent configuration. And we're going to add service HTTP. Okay, done. We're also going to add it to our trusted zone. Add service HTTPD. And then we're going to reload the firewall rules. Okay. Now, strictly speaking, because we're in a sandboxed environment inside virtual machines, we wouldn't necessarily need to configure a firewall because this is NATed to the outside world. So our virtual machine is invisible from a network perspective to the outside world, but it's still a good habit to get into to make sure that your firewall is configured pretty tightly and you're only opening the parts that you need to open. Okay, so let's enable and start our web server using system control, system, CTL, enable. So that allows us, that makes sure that the Apache web server starts when the OS boots up, httpd.service. Okay, so that's created the symlinks, so that's enabled that. Now let's start the service. System control start, httpd.service. Okay, and then we can now also check its status and make sure it is up and running. And there we go, we can see it's active and it's running, so no problems there. Right. Okay, so let's check now and using elinks, which is the command line web browser, and we'll point it to our local host on IP address 127.0.0.1, which is our loopback address, and we should hopefully see a PHP info file come up if I put the right command in. Yep, and there we go. So that's our Apache web server configured, installed and working, and it's also, we've got our PHP version 7.2.1 in. So everything's running off of there as we'd expect it to be. Okay, so we can Control C to quit out of the elinks web browser. So that's PHP and Apache set up. Okay, so now we're going to move on to Postgres. Okay, Postgres is a relational database very similar to MySQL and other relational databases such as those provided with Oracle. It's pretty much of a muchness which one you use. Postgres does have additional functionality in terms of things called OIDs, which are object identifiers, and it also has a greater set of functionality for writing database functions inside the database itself to help with the development of more complex queries. So let's go ahead and install Postgres onto our system. So CentOS does provide a baseline level of Postgres in there, but it's quite a dated version. So let's install a better one from Postgres themselves. So yum install. Okay, HTTPS downloads. / repos / yum / 9.5, which is the version we're going to be installing, / Red Hat, because CentOS is based on the Red Hat OS, HEL-x86_64. Again, if you're using a 32-bit operating system, make sure you pull the right one in. /pgdg CentOS 95-9.5-3 npm. No, I haven't. Downloads. Okay, there we go. So that's installed that. So that'll give us access now to a slightly better version, which is pretty stable and well supported. There are newer versions of Postgres available, including Postgres 10, but as we're developing for a real client, we need to ensure that we're using something that's stable and well supported. Now, PostgreSQL 10 is pretty stable and well supported, but this also includes a number of tools such as support through PHP pgadmin, which is a web interface similar to PHP myadmin for MySQL, and pgadmin 3, which is a desktop tool, works very well with 9.5. Later versions beyond that are a little less supported. So let's go ahead and install Postgres and the supporting libraries. So again, we can use yum group install. We're going to be installing a group of packages, and again it's PostgreSQL. Again, the capitalization is important. Database server 9.5 pgdg. Okay, let that roll. Alright, so this is bringing in the support tools for Postgres, the various libraries, and the actual server itself. And we can see that's coming from the Postgres repository there. So let's go ahead and install those. Shouldn't take too long. Okay. Right, now in order for our PHP installation to access and work with the Postgres database, we need to bring in some PHP libraries. So yum install PHP PGSQL. Okay. Again, this is coming from the REMI repository as opposed to the standard Red Hat CentOS one. So we're maintaining our versioning. So let's go ahead and install those. Right, now we need to initialize the database. So this is under, so we're just going to run a setup script. So user PGSQL 9.5. Look in the bin directory, and it's Postgres 9.5 setup. Setup, and then we want to initialize initdb, initialize the database. Okay. Could take a minute or two. There we go. So that's the database initialized, and now we need to do what we did with Apache, which is ensure that we enable the Postgres database to start when the system starts. So system control enable system control Postgres 9.5 service. Okay, that's good, that's done. Now let's start the database server. Okay, and then again we can just check its status using the system control status command. Okay, we're good, we're up and running. Right, again, let's change our firewall. So equals trusted minus. This time we're going to add a port. Okay, which is port 5432 over TCP. Okay, and then again we're going to reload the firewall. Alright, we're going to need to amend something now with SE Linux. SE Linux is a fairly robust, in fact it's a very robust, role-based access control security element built into the Red Hat, CentOS, Fedora operating systems. It's part of the enhanced security processes which enable Red Hat to run in the enterprise, and also it's sanctioned by a lot of government agencies. And it really is secure. It can drill down to what a particular user or a particular process can do on a file. So it really is fine-grained permissions. So we're going to have to adjust SE Linux to allow Postgres to connect to the network and various other things to connect to it via the network and via HTTP. So set bool. So we're going to set a Boolean value. Oh, sorry, SE set bool, set SE bool, minus P, and it's HTTPD underscore can underscore network connect underscore DB, and then we're going to set that value to 1, which is true. Okay, spot the typo. Another typo, sorry, my mistake. Right, there we go. So that's that bit done. Okay, now we've got installed Postgres. Postgres, like Apache, has its own particular user associated with it, and that just happens to be Postgres. That's also the name of the default database, which is built into the system. So in order to be able to do that, we need to switch to the Postgres user to perform any Postgres related operations. So we do that by issuing su minus and then Postgres, which is the user. So that's changed the bash prompt. If you look down there, that's actually changed that now. So now we're running in as the Postgres user. So we need to log into the actual Postgres database using the command PSQL. Okay, and there we go. So that's changed the prompt again, and we're now logged in as the Postgres user into the database. So we're going to change the password. There we are. We're going to change the password to Postgres, or for Postgres, I should say. So we'll enter a new password. You can make this whatever you want again at this point, but again, please remember this password. Okay. Let me ask to enter it again. Hopefully I've typed those the same. So that's great. And then also we're going to install the Postgres admin pack, which are some additional features. And we can do that here. So create. Okay, so create extension admin pack, and that should give us a message there, create extension, and then we can quit using the \q to quit out of the database. So that's put us there back to the Postgres user shell. Now there's some commands that the Postgres user can access from this. So we're going to create a new user. Okay, I'm just going to call that Bren because it matches the username of the standard user that I created in the system. Again, you can call it whatever you like. So create user Bren. Yep. And then we're going to create a database. Create DB. Okay, and again, you can call it whatever you like, but I'm going to go with TWP _DB. Okay, for the Will Writing Partnership database. Okay, that's that created. Right, now we're going to log back in to Postgres, the actual database again. Okay, and this time we're going to set a password for the Bren user that we just created and grant the appropriate privileges on the database. So alter user Bren with encrypted password, and then put the password in single speech marks. And then semicolon at the end. Okay, so that's altered the role. And then we're going to grant all privileges on database TWP _DB to Bren. Okay, that's that done. So once again, as before, quit out of the database. Okay, which we've done, and we can now exit the Postgres user with the exit command, and that will return us back to our root prompt. Okay, let's clear that down, clear a bit of space. Right, so now we need to just change some of the configurations relating to the Postgres database to make it work a little more as we'd expect across the network and various other things. So again, using Nano, we're going to open a file for our Postgres connection methods. So this is in var lib PGSQL 9.5 data, and then it's pg_hba.com. Okay, again, a scary looking file, but most of it's comments. But this relates to client authentication and which particular methods that a client can use when they're authenticating against the system. Okay, so this top one, which is for Unix domain socket connections, so those are kind of internal local connections, you could say. Right. We need to change these to MD5, so it looks for our MD5 passwords. Like again, our local IPv4 connections, MD5. Although we won't be using IPv6, it's still a good habit to change that. Okay, and then we want to add a line to allow connections from a specific host. So let's just stick a comment in there. So IPv4 remote. This is pretty insecure, so you might want to tighten those up in production environments, possibly specifying a couple of ranges, especially if your database is on a separate server or you're just dealing with internal connections from Apache. But this will do for now to help us with development. So host all. Okay, this is going to set the IP address. So 0.0.0.0/0, which indicates any IP address in any subnet. And again, we're going to set that to MD5. Right, okay, so that's all done. Let's just Control X to exit, yes to save the buffer, and we're going to write it back to that file. So that's that done now. Right, so by default, TCP/IP connections are disabled so that users from other computers can't access Postgres. So in that previous step, we've allowed them to access and to use the password. But to get them fully connected from other users, we need to actually edit the Postgres database configuration file itself. So again, using nano, or you can press the up command to go back to the previous one because we're in a similar place. So it's var lib PGSQL 9.5 data, and then we want the PostgreSQL.conf file. So we'll open that up. Okay, again, another scary looking text file, but it's no big deal. Okay, so we want to scroll down and we're looking for a line that says listen address. There we are, there it is. Okay, so we want to uncomment that line. Yeah. And then we're going to change it from just the local host. So that would be just allowing it to listen on local host connections. And we're going to allow it to listen from any connection. Okay, so we'll save that file. And then we'll restart the web server using the system control function. System control, restart, post QL-9.5 service. Okay, and again, just to be certain, let's just check its status. And that's fine. Right, so another tool that we want to install is we want to install PHP pgadmin, which is a web-based administration utility written in PHP for managing Postgres databases. When we build our development machine, we'll also add another set of other tools. However, this one is available directly over the web server. So install PHP pgadmin using yum install PHP pg, and again, the uppercase characters are important. Okay, so let's bring that in. Okay, that's that done. So by default, you'll access pgadmin via the local host, but in order to gain access from remote systems, such as you might want to do if you're managing web servers and things, we'll need to amend the php pgadmin.conf file. So again, using nano, and this one's in etc. httpd, and it's in the conf.d directory, and it's php pgadmin.conf. And we can see the standard PHP configuration file in there for the web server. Okay, so this file highlights which directories we need to use and how we can access those directories. So this is for various different versions, but we want to change this require local line to require all granted. And then we want to change this line from deny from all to allow from all. Okay, and then we'll save that back into the Apache config file. So that's configured Apache. Okay, now we need to adjust the access permissions, okay, by which PHP pgadmin listens for various different connections on. So nano -w, and then we're going to go into etc again. PHP pgadmin, and it's config.inc.php. Alright, we want to scroll down and look for a line with config server 0 host. Okay, which is that one there. And so we need to change that, and we need to add in localhost. So this is just going to connect back through our local host from the web server back to Postgres. Okay, now also by default, PHP admin will not allow the default database user, which is the Postgres user we used before, to access via PHP pgadmin. So in order to do that, we need to change the extra login security from true to false. We just have to find that. There it is. So that's from true to false. Okay. And this permission here will only allow you to show the databases which you own. Now, again, in a production environment, I probably set this to true, but I'm going to leave this as false because we want to be able to see the Postgres users database as well, in case we need to amend any permissions or anything in there. So we'll just leave that as is, and then so it's Control X, Y, save the file. We'll restart the Postgres server, and then we'll restart the Apache server. So enable, system control, restart, and Postgres. Service. Okay, and then we'll also restart httpd.service for the web server, sorry. I see. That's what you get for talking and typing at the same time. There we go. Right, so hopefully that should be our LAPP stack set up. Okay, so we can just check that by going to elinks, http:// so it's 127.0.0.1 / and it's PHP PG admin. Should have guessed. Let's just hit enter, and there we go. So that's PHP PG admin on the server running. So that's a LAPP stack, which is Linux, Apache, PHP and PostgreSQL, fully installed, up and running, ready to go. So in order to create the development host, okay, we'll make some changes in the next video. But for now, to end this one out, you can shut down the host using shutdown -t now, and that'll shut down the host, ready for us to clone it and make some changes as part of the next setup.